Welcome to another video episode on my Raspberry Pi 2 running Ubuntu Linux and connected to an HDMI monitor, a serial Pi Plus board for connection with Minicom, a network cable for connection with VNC, virtual network computing, and a band cable to connect the GPIO to this breadboard with some electronics and some fischertechnik. Fischertechnik motor with a propeller, fischertechnik LED and phototransistor. And there's also a button, etc. Also with VNC is this, right here, my Mac, which is connected to this monitor and shows VNC. Here I have a bash file through which I can control the GPIO, and that's also the focus, controlling GPIO. So right here the source code, and here I try to execute everything, and I will show you a bit later. And last time I had to rewire a few things, because despite the length, physical length of the GPIO, and then I'm talking about this. And yes, this is also GPIO, those are the pins, and this band cable connects them. Despite the number of pins, wiring Pi doesn't support all of them, unfortunately. So I had to rewire, and what I want to do with Bash is still getting to try the input, because with C and C++ I can read the input, and that is something I achieved last time. So with, for example, this light, put it right here and run. Motor runs right here, and okay, one LED doesn't work, but the wiring is a bit out, I notice. So now it probably will work. No, still doesn't. Not nice. Now it works. Alright. Anyway, that's for introduction. Let's go to VNC and see whatever I can do. So right now VNC with two virtual desktops, and for some reason this is gone black. No clue why, but it does work, because this is the source code of the C file, this is the source code of the C++ file, and you can see here output definitions, same. And then the difference comes because here it says printf, and here I use cout. Yes, I can use printf in C++ as well, but why use it when you have a much simpler notation using cout? Then last time I really found out which pins to use, and that enabled me to diversificate, or whatever you call it, between a button and the phototransistor. So let's run it again, this time with a button, or maybe both, although I want to see the motor go as well, so let me put the motor right here. Then I don't want to obscure this LED either, although it's now no longer wired. I have to redo. Yep. That should be working. So here and strong light. There we go. And nice. So button pressed and photoresistor. Very nice. That's exactly what I want. Now the same thing for the C++. And there we go. Oh, no light. Hey, I want it to light up. Yep, it works. It says button pressed and phototransistor. And the motor works, obviously. So that still goes. Now obviously it should be working with Bash as well to get everything working. Although C++ is the most important, because in another project where I used the Robot operating system, it didn't work at all. And this test is showing how I can set it up, but the question is, can I use it? Can I do that using setup with ROS? Not sure yet. So this clearly is working nicely. Yeah, next test, Bash. Alright, so here we are at the Mac. Well, using the Mac for VNC on the Raspberry Pi 2. And in the meantime, what should I do? Well, this is all working nicely. What does not work is the input, which I have defined here. I have used here GPIO 11 and 22. While looking at the C code and the C++ code, input says 17 and 22. So I should use 17 and 22, provided that's all correct. Yes. And then here I should use the same thing. Although, what is this? 11. I don't see any 11 here. And no, there is no pin 11 at all. 18, 24, 25, 12, 23. That's a bit different. So 12 is there. 24, 25, and 18 is there as well. Yes. And those are 5, and then 12 and 22. Wait. Yeah, black on blue doesn't read nicely, but let's just say this is. And then I should echo, echo, echo. All right, here we go. And then this is then supposed to be the output. So let's keep that the same as in 17 and 22. Let's just see if this works out. And unfortunately you can't watch, although yeah, we can. No such file or directory for 12, 19. Alright, something goes really wrong here. I need to check all the numbers again. So let me do just that. Alright, so what I need to use are the following numbers. And I have to go to this one. So the numbers should be yes, 12, 18, 24, 25 and not 11. All numbers are then 23. So one of them I should change. Let's do this one, 23. And then I need 17 and 27. So let's change this in 7. Then the direction. Out goes 12. Out goes 18, 24, 25 and 23. And in goes 17 and 27. So 12 and 16 doesn't even exist. That should be then 23. And well, GPIO 23 should be this one then. And what are these values? Well, this is 27 then. So, new attempt. What do we see? A motor runs, LED burning, and another LED doesn't burn because it didn't work, wasn't wired. Now all 3 LEDs and the motor go. And now the question is, now I'm lighting the phototransistor. Yes. Now I am pressing the button. So the other one should become 1. And that's exactly what happens. So now I will be pressing both. And both should be 1. And they are. And this proves that I had wrong GPIO numbers, ports. Why the heck it does give device or resource busy, I'm not quite sure. I could use sudo maybe, but I give exactly the same thing. So that's not a problem. This is the correct one. And yes, this proves that the bash does work. No need to show that on camera because you have seen that, but the output, this part of the output is what matters this time, because now I have proven that it does input as well. And that's good. And I just realized I can actually show you on cam. So I'll first start and then pull up VLC. So here goes and here goes. So this is what you see happening, and I'll have to do it again. Show you, and there you see everything working nicely. And that's what it is about. So yeah, I could show you. Another thing that I maybe could show you is via my tablet. Power is almost gone, or battery is almost gone, but I have, and I can't show you bigger, best GPIO text. And all I have to do is press enter here, and then everything works if I am in time. And I was in time with this one, so I can try again. Yep, and press enter. Oh yeah, that's the wrong program. This is the correct one. Okay, I have to correct it. And start, pressing the button. And for some reason it is not acting, it's not acting like it should. I think it may be very much due to the battery with bad connection. Alright, enter, pressing a button. And there it did go, with the button being signaled. And let me try to show you what is actually written. Yeah, you see the camera on front, but actually I hope you can see the text. So that is with the tablet, with power of it almost gone, and there it goes completely. And restored again. So yeah, actually that is what I want to show you. I can do more, but I didn't prepare that, so I think this is a nice way to wrap this. So using C++, C and Bash via tablet, as well as via my Mac on VNC, that is, oops, that is a timeout. I've shown that on Ubuntu with C and C++ and Bash you can control GPIO, and you can read input and control by output. The only thing that I not really do like is the fact that these ports, the higher GPIO pins, are not usable with wiring PI. But then so be it. So that is, I think, the conclusion of these tests. Thank you for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. You can also follow me via Instagram and Twitter. Sorry, Instagram and Twitter. And you please support my blog and videos by making a donation via either PayPal or Wired, which is banking. And you can also become a patron and have your name mentioned as a supporter. Your name will be mentioned on my website, and depending on the pledge you make, also with my videos. All information, including how to become a patron, etc., under this video. URL of my website is there. Social media names, you mention it. That's it. Maybe to be continued. Have a nice day and bye bye.